Hello, my name is Aurelio Garcia-Ribeyro. I am a Senior Director of Product Management at Oracle. I joined the Java Platform Group at Sun Microsystems while JDK 7 was being developed. Today, we will talk about JDK 18 and see some of the new features in the latest release of Java. JDK 18 is the first release of 2022. It's the 10th release since we switched to a semi-annual release cadence and the first release after an LTS, which means that this is where we actually get more versions to choose from. JDK 17 replaced JDK 16. So if you were looking for commonly supported releases, we used to have 3 to choose from, 17, 11, and 8. With JDK 18, we finally get 4 to choose it. If we want to look a bit forward, JDK 18 will be superseded by JDK 19 in about 6 months, in September. Then JDK 20, March of 2023, and in September of 2023, we will arrive to the next LTS, JDK 21. Since we are now releasing LTS versions every other year instead of every 3 years, we now have to wait only a year and a half until we get the features that are introduced in JDK 18 on an LTS release. Another important change that was announced 6 months ago is the introduction of a new license for the Oracle JDK. Under the new license terms, you can use the Oracle JDK in production at no cost. JDK 18 will be launched under this new license. We plan to launch all new versions of the JDK under these terms. The LTS releases will be offered under the free license terms for no less than 3 years. So you will have enough time after JDK 21, the next LTS has come out, to migrate from 17 to 21. Or if you prefer, after 3 years of JDK 17 launching, 1 year after JDK 21 releases, we will switch the licenses under which we offer JDK 17 updates, and we will make those available for customers and also for development, personal use, and to run other Oracle products. Let's take a look at the features delivered in JDK 18. We have 9 JDK Enhancement Proposals, or JEPs, delivered as part of JDK 18. As you can see, we have some improvements in the tools. We have a new tool and an improvement on an existing one. We have done some changes into the libraries. As in previous versions, we have some previews and Incubator features that you can try out and give us feedback before they get added into the standard. And we have a terminal deprecation of a feature that we would like to remove from the JDK in some future version. Let's look into these 9 JEPs with a little bit more detail. The first one is JEP 408. We're going to introduce a simple web server as part of the JDK. It's fairly common when trying out new code to need a simple web server. The JDK team that develops the network APIs ran into this quite a bit. So they figured, rather than bring one along, why not include a very simple one in the JDK? JWeb Server is a new command line tool. It's a minimal web server. It serves only static files. It only supports HTTP 1.1. It does not support HTTPS. These web servers should be pretty useful, particularly for prototyping and testing. There is also a small API so that you can programmatically create and customize it. If you call JWeb Server without any options, it'll run in the foreground and it'll bind to the loopback address. That's 127.0.0.1 on port 8000. And it will serve files from the current directory on which you started it. You can also pass some options if you would like to change the address or the port. You can pass the D or directory option and tell it not to use the current folder, but some other folder that you choose. The output format will allow you to determine how verbose the login is, and you can change the port. Julia Boss, the owner of the JEP, has a session where she covers this particular tool in much more detail. JEP 413 introduces an enhancement to Java JOK that will make it easier to include code snippets in your Java API documentation. It was always possible to include sample code, but there were some problems with the prior formats. It was not easy to make sure that the code was complete and correct. With the changes that we're introducing in JEP 413, it will be possible to use external tools to validate that the sample code is correct. You will also be able to use some syntax highlighting, which is pretty common nowadays, but wasn't possible before. In this example, we are introducing some inline snippet of code. So you can see by that snippet tag, we use that to put some code inside, and that's supposed to be in the code itself. Now, if you want something a little bit more complicated, you can use the snippet tag to refer to an external file. And by using the region attribute, you can choose which part of the code in the external file is shown in the resulting documentation. If you use the replace tag, you can modify some of the text in the part that is going to be shown. And that's very useful if you want, for example, the text to be complete so that you can have your automated tools validated and yet use the replace tag to remove anything that's unnecessary to keep the documentation simple. You should expect to see more sample code in the JDK API, in the JDK API documentation, thanks to this new feature. JEP 400 establishes UTF-8 as the default character set for all of the standard APIs for processing text. That's for reading, writing, and processing. If you didn't pass an argument, well, if you don't pass an argument, there's always the default character set being used. Prior to JDK 18, this was dependent on many factors, like the operating system and the user locale. Developers sometimes try to set the default encoding by passing -dfile.encoding, but this was never supported. You will also notice if you try to change the default set programmatically that fails, since the default is selected when the runtime loads, and it cannot be changed after that. To make matters worse, not all of the methods that didn't require that you specify as a char set would use the same defaults. The APIs from java.nio.files, when you don't specify a char set, will use UTF-8, even in earlier versions of the JDK. JDK 18 then solves the problem of these not being sure of which version will be the default by making UTF-8 the default for all methods that do not receive a character set as a parameter. This change has the potential to introduce some compatibility problems. So it is possible to revert to the prior behavior where the default set from the operating system was used if you run into problems. JEP 418 introduces a service provider interface for Internet Address Resolution services. The JDK currently uses the operating system's native resolver, which typically uses a combination of localhost file and the DNS or domain name system. The resolution with current INET address API blocks in an operating system call. This is a problem for the coming virtual threads in Project Loom. Now that we have a standard interface, this allows developers to plug in a new resolver that can implement DNS client protocol directly without blocking. Now, as part of this JEP, a proof of concept resolver is made available so that it can be used as a starting point for more complete providers. JEP 4.16 re-implements core reflection with method handles. This is likely to be invisible to most developers, even those using reflection. Before this change, there were different internal mechanisms for reflective operations. With JDK 7, we added method handles as yet another way of handling reflection operations. With JDK 18, we re-implement Java lang reflect on top of method handles, establishing a common baseline. This will make it easier to upgrade reflection when new features are added, such as those envisioned for Project Valhalla. JEP 4.20 brings for a second preview pattern matching for switch. Now remember, preview features are not enabled by default. You have to tell the compiler that you want to use preview features, and you have to tell the runtime when you're running the application that you want to use preview features. That is so that you don't unintentionally burn a preview feature, say, into a library that you're going to hand out and somebody expects to run in some future version. Pattern matching for switch enhances the programming language with pattern matching, well, for switch, which makes expressing statements much more clear. Let's take an example. If you use the current switch statement, it works on just a few types: numerics, enums, and strings. If we want to use patterns to check for a certain number of possibilities, we could use a chain of if-else statements. It would look something like this. Using pattern matching, however, we can make this much clearer. And as a bonus, this code is optimizable by the compiler. Remember that the case statement has to be exhaustive. So in most cases, like in here, you will want to add a default value at the end. If you used sealed classes, you wouldn't need to use a default value if your labels covered all of the cases. Now, in this example, there's something important missing. Traditionally, switch statements and switch expressions throw a null pointer exception if the selected expression evaluates to null. In most cases, testing for null is done outside of the switch statement. But now that case labels will allow type patterns, we can integrate the null handling into the switch statement. There. This makes the code easier to read and maintain. After a successful pattern match, we often need further tests, which can lead to cumbersome code like this one, where you have the switch statement and then an if right inside. We can improve readability if the pattern supported a combination of pattern and Boolean expressions. So that's what we have. Guarded patterns allows us to write this in a much clearer way. The first case matches a string of length 1. All other strings are caught by the second case. There are a couple of new gotchas that could arise with pattern matching for switch. The first one is that a pattern could dominate later patterns. It is possible to have an expression match multiple labels in a switch block. This is allowed, but they must be placed in the right order. Here, we have code that is very similar to what I just showed for guarded patterns, but with the order of the case statements reversed. Since the first label will catch all strings, including those of length 1, the second label can never be reached. It is dominated by an earlier case. This will result in a compile time error. This is one of the areas that had received some improvements from the first preview in JDK 17. If you use now constant labels, they have to appear before a guarded pattern of the same type. Another new possible error is to have a fall through when declaring a pattern variable. In this example, if the variable was a character, it would go ahead and print character. But as there is no break statement, execution would flow to the next label. But since the variable I has not been declared, has not been initialized, we would get an error. It is therefore a compile time error to allow flow through to a case that declares a pattern. Falling through to a label that doesn't declare a pattern is fine. JEP 419 brings back for a second incubator the foreign function and memory APIs introduced in JDK 17. These APIs are meant to provide an easier to use replacement to using JNI for accessing code and data outside of the Java runtime. Also back for another incubator is the vector API. This was introduced, I believe, in JDK 16, 17. I don't know if it's 16, 17. I know it was second incubator in 17. Vector computations allow you to execute code operations on vectors instead of single operands. At a time, this can result in significant performance improvements. Hotspot supports auto-vectorization, so sometimes it can detect when a scalar operation can be transformed into superword operations and mapped to vector instructions. However, the set of transformable operations is limited, and it's fragile to changes in the code shape. With this API, it will be possible to write very complex vector algorithms in Java in a way that it's far more predictable and robust. Here's a conceptual model of a vector operation. Instead of needing to repeat operations, we can achieve the same result with a single pass. These type of operations are very common in machine learning and cryptography. So when these APIs are finalized, we can expect libraries that provide those services to become significantly better. In JDK 18, we terminally deprecate the finalization mechanism. This will get us better control for resource closing. Finalization was meant to avoid resource leaks by having the garbage collector do the closing of any resource that was opened by an object before it reclaims it. However, these had many critical flaws. There is an unpredictable latency, since an arbitrary amount of time can pass between an object becoming unreachable and the finalizer being called. The finalizer code had no restrictions, and it could do anything it wanted, including saving a reference to the object, which would, in a sense, resurrect it. There was no way of turning off finalization, even if it was not needed. And finalizers run on unspecified threads, so they can fire in any arbitrary ordering. These problems introduced security vulnerabilities, several performance penalties, and they complicated the programming model. Now, we know about these issues for many decades now, and we're marking them for removal in a future version. Since JDK 7, we have tried with resources as a better alternative for many use cases. For some long-lived resources, or those that do not permit the close method, we have introduced since JDK 9 the cleaner API. For backward compatibility, finalization will remain enabled by default for now, but you can pass as a command line flag to disable it so that you can find any instances where you're using it and perhaps remove them before the methods get removed in some later version of the JDK. These 9 JEPs represent but a small fraction of the features that are made available in JDK 18. They're only the largest or more visible ones. But if we take a look at the JDK 18 release notes, we will see that there are hundreds of smaller changes. Most of them will not be of interest to most developers, but I do recommend that you go and spend some time looking into the features listed in the release notes to see if there's anything else of interest to you. Let's take a quick look at some of them. JDK 8 introduced string deduplication for the G1 garbage collector. With JDK 18, this optimization is added to the other garbage collectors. With this enhancement, it will be easier to debug crashes in the G1 and the G2 compilers when using some of the new features. Here's a change related to the finalization one. Since we deprecated finalization, we have updated Java flag recorder so that by default, it will identify runtime classes that use finalizers. Here we have another example of careful pruning with plenty of notice. JDK 9 introduced safer alternatives for most use cases that relied on sun, misc, and safe methods that return offsets. JDK 18 deprecates the older methods so that they can be removed in some later version of Java. Okay, here's another interesting one that may impact some of you. SHA-1 has not been considered a secure option for signing code for many years now, but there's still a large number of SHA-1 signed jars being used. JDK 18 will treat jars signed with SHA-1 as unsigned. As you can see, those that have been signed prior to this date in 2019 will still be considered signed. Now, this is true for JDK 18, but if you look at the Java crypto roadmap, you will see a warning letting know developers that we plan to do the same to update releases of all supported versions sometime later this year. As usual, there are many more changes than what is covered in the JEPs. Well, that's it for the features. Let's take a look at some of the other details of JDK 18. The first question, where to find it? Oracle offers the latest version of the JDK as well as updates for prior versions. This site, oracle.com/Java download, you'll get to it as the first hit probably if you search for download JDK. Includes links to download JDK 18, JDK 17, and JDK 11 and JDK 8. It is also possible to programmatically access the versions of JDK 18 and also of JDK 17. These URLs are available for all of the releases that are offered under no fee terms and conditions. For now, that is 17 and 18. These URLs, you notice that it says latest. They will always give you the latest version of that release. You can use these in your scripts using curl or wget to download them. If you add a SHA-256 .SHA-256 at the end of a package name, you will get the checksum, so you can validate that you downloaded correctly without any errors. Notice that the file name here is just 18, or if you wanted to download 17, you would say JDK 17 Linux x64. This URL will give you the then current version. So if you try this today and you plug in JDK 18, you will get the GA version of 18. If you plug in JDK 17, you will get the current version of JDK 17. At the time of this video, that is 17.02. Now, if you wait until April of 2022, when we get to the next critical patch update, these same URLs will deliver 18.01 and 17.03, depending on which ones you choose. These URLs will remain active and valid for as long as there is a current version of JDK for that release available to you under the NFTC license. That means that the latest URL for JDK 18 will not work after the release of JDK 19. The ones for JDK 17 will continue to work until, remember that graph at the beginning? Until we've been 1 year after the release of JDK 21. Now, this is the recommended set of URLs to use. But what happens if you don't want the current version, but a particular release? Then there is also the archive URLs, which are very similar, but instead of saying latest, they have archive. And instead of just having in the file name the JDK version, they have the full version. So for example, after April of 2022, if you wanted 18.01, you can use downloadoracle.com, Java, 18, archive, JDK, 18.01, the operating system and architecture. And then we have TAR-GCs and RPMs, and for Windows, we have EXEs and MSIs. So you can get into, from our website, the complete list of possible values. Now, hopefully this will make it easier to automate and get the latest version of Java. Which certified system configurations? As you would expect, it's very similar to the system that we support JDK 17 on, with the usual updates. So we have Linux on Intel, on x64 systems, Oracle Linux, Red Hat, Ubuntu, and SUSE. We also offer Linux on ARM64. We have Windows, including Windows Server 2022 and Windows 11. And for Mac, we offer both for x64 and for ARM64 systems. Most of the information in this presentation is listed in the openjdk.java.net project for JDK 18. You will see here the schedule. You will have a link to each one of the JEPs that I've listed. And if you click on those, you will have multiple pages worth of information with links to the release notes. I'm sorry, not to the release notes, to the discussions, aliases used when those features were being written. So if you have any question, why did they do something? Wouldn't it have been better if they did something different? You can look at this, at the aliases listed in each one of those JEPs, and you can see all of the conversations that went into delivering the feature as it is. And with that, I hope you found this session useful and that you enjoyed the rest of the sessions. Thank you.